Hello everyone, my name is Hannah Gratian, and I will be presenting today on the experience of phantom pain. Dr. Ramachandran explains in his book Phantoms in the Brain, Chapter 4, of two case studies, one of Philip Martinez, who had a 1984 accident with his motorcycle, jerking his left arm from its socket and paralyzing the arm, unfortunately. After 1 year, the doctors decided to amputate. 10 years later, Philip was still experiencing pain. Robert Townsend was the second case study. Robert lost his arm due to cancer, 6 inches above the elbow, and he perceived phantom pain of digging nails into his hand. In a 2005 study, Karkin Tyaz and his team studied pain and phantom limbs of amputees. These were victims of war. Their pain luckily decreased over time, but 60% was spontaneous, 20% was under the influence of physical therapy, and 20% was resistant to pain. Dr. Ramachandran, quote here, "These ideas imply that pain is an opinion on the organism's state of health rather than a mere reflective response to an injury. There is no direct hotline from pain receptors to pain centers in the brain." Rear and his team in 2014 linked pain with increased mortality, that when suppressed or destroyed the specific TRPV1 pain receptor, you can have an increased health benefit. Pain receptors. There's a myth that nociceptors means pain. This is not. This is simply a receptor that indicates either thermal, mechanical, or chemical signals. These C fibers travel up to the spinal cord and connect to afferent fibers, which connect down back to the skin and initiate a response. The C fibers connect to the dorsal root of the spinal cord. The brain pathways that are involved with this are numerous. There's the thalamus, specifically the ventromedial nucleus, the insula, and the anterior cingulate cortex, and more. The nociceptors in the skin, one of the specific ones is the Pacinian corpuscle. This is a mechanical sensitivity, so one of the types of nociceptors. In this diagram, we see that the stimulus starts here. The noxious stimulus, the mechanical, thermal, or chemical, goes to the stimulation, goes to the dorsal horn of the spine, which is if you're getting it from your hand, it's going to your back, the back side of your spine. It goes up to the pain neuromatrix that has the anterior cingulate cortex, insula, the prefrontal cortex, the amygdala, the hypothalamus, and the sensory cortex. It also has the inflammatory and biomolecular mediators. And then there's a separate section for cortical limbic striatal circuit. That is attention, that's emotion, that's every response that you have. And then there's the actual act of reacting to the stimulus. The afferent fibers are sharp pain, while the C fibers are intense and lingering pain. The Pacinian is the mechanical sensitivity, as I discussed before, and it is either excitatory or inhibitory. The peptides, the neurotransmitters, and the lipids and neurotropins excite the nociceptors, which lowers the activation, inflammation, as we see in the inflammation guide right here. I was really curious to see what exactly the insula did. The insula and the anterior cingulate cortex in particular. The insula had the perception of pain, basic emotions, addiction, motor control, sense of self, reading emotions, and social cues, while the anterior cingulate cortex had the affect regulation, ability to control and manage uncomfortable emotions, and mainly avoidance. There are several ways that we have learned to lessen the attention to pain. One of these is called TENS, transcutaneous electrical nerve stimulation. This is simply a small stimulation to either the muscle or the nerve cell in order to activate it and lessen the pain, because pain can be learned, unfortunately. So this may be why as a child your parent might have told you to, if you fell down, that the pain wasn't too bad, that you didn't react as much. The parent didn't react. They said that it was fine, that you would be okay. This is also the case for patients and nurses oftentimes. There's a test that some nurses perform. You put pressure on the top of lower back patients who have lower back pain, on top of their head, and if they seem to feel pain, they're perceiving pain more than actually feeling pain. There should be no pain felt during this movement. It's a test to see how much attention you are paying to the pain that you are perceiving, because pain is a signal. There are also, with the 2 patients that Dr. Ramachandran had, he used the mirror box, and because visual perception is critical key in this, he also used virtual reality and electrical stimulation therapy as well. So these are some of the many ways that we can pay less attention to pain and hopefully lessen patients' pain in future. Here are my references, and thank you so much for watching this. Cheers.